Exercise 6.3, the numerical model. Now, in linear motion, there is one thing you have to understand about scalars and vectors. A scalar quantity is something that has a magnitude but no direction. A vector quantity is something that has a magnitude as well as a direction. This shows us there's a difference between something known as distance and something that's known as displacement. They are both measurements of distances, however, distance is a scalar and displacement is a vector. Distance just tells us the entire distance travelled without relation to any distance, whereas a vector is just based on the displacement shows the difference between the starting point of travel to the difference between the final point of travel. For example, if you was to go through a bunch of streets and alleyways, cutting and turning, that would increase your distance, but the vector distance is only, as displacement, is only from starting point to the ending point, and therefore would be a lot less. This is an example of a vector diagram showing the forces of an object. For example, this would be where the object is. There is a force of 4 newtons acting in this direction, a force of 2 newtons acting in this direction. This isn't how an object in real life would react to these two different forces in the two different positions being placed on them. They would obviously move in a way when they are both combined. It doesn't go right and then up when they're both being applied at the same time. So this is the forces that have been added, and this is the resultant force. So as you can see, the 2 newtons has been put over to the right side, and this is the hypotenuse of the triangle that will equal around 4.5 newtons. You do this by squaring them both, adding them together, and then square rooting that, and that would equal about 4.5 newtons as the resultant force of this vector diagram. Speed is a measurement of how fast something is and how much time it takes for that something to travel a certain distance. This is done by doing distance divided by the time taken for that object or that body to pass through that distance. This is in meters per second squared. Meters per second to the -1. It is non-directional. However, velocity is speed, but in a given direction. Velocity includes a direction, and therefore it is a vector. If an object was to travel from the left side of this screen over to the right side of this screen, but an object from the right side of the screen was going to travel to the left, this would be in a negative velocity to this initial velocity that is going in the positive direction. And no matter what situation, if there is a given positive direction, an object that's going in the opposite direction would be in the negative direction to that given object. This distance over time graph shows that if the distance divided by the time, which would equal the gradient, which is this straight line, is the speed. In this one, it's showing a straight line through the origin, showing that this is uniform speed. Same speed the whole way through. If there were a point on this distance time graph where it would cut off like this would mean there is 0 distance travelled over that period of time, and then means they would have stopped. The gradient is distance divided by the time, which is equal to a uniform speed. This graph here shows a velocity over time graph for a constant acceleration of the object. So this first part of the graph shows the gradient is equal to the acceleration, as acceleration is equal to the change in velocity over the time taken. This flat section here shows that there's a constant velocity, as it is staying at the same velocity over a period of time. Again, in this part, there is an increase in velocity over that time, or change in velocity over that period of time. Therefore, it's accelerating. This point here, 6 seconds or 7 seconds even, is decreasing in velocity, so it's a negative change in velocity. So it's not negative acceleration, it's deceleration, which is equal to negative acceleration, but it's deceleration as it's slowing down, going down to 0 as it gets to 10 seconds. The acceleration of an object is defined as in an object that is constantly accelerating is the difference in the change in velocity over the time taken. Therefore, it's the meters per second to the minus 1 over seconds. So acceleration is meters per second to the minus 2. This is defined as a change in velocity over a given unit of time. This diagram here is a velocity over time graph and can show that this is a positive acceleration. There is 0 acceleration here, so it's traveling in a constant velocity. The negative acceleration shows a deceleration of the object over a period of time. The area under the curve or under this graph can be calculated as the total distance traveled of the body over that period of time. So you would do 3 times a, add this to how much the area of these two triangles here are, the positive and negative acceleration, and that will equal the total distance traveled over the period of 10 seconds. This graph here is the final graph, and it shows the displacement away from a particular point, stated on here as someone's home, over a period of time. It shows that they started 20 meters away from their starting point, made it to there, the opposite direction, was back, even further away, 40 meters, and did the exact same over this period of time in a negative and positive